Polygons are 2D shapes with 3 or more sides. Let's look at the properties of what makes polygon a polygon. So number one, it should be a 2D shape, or we can say that it should be a flat shape. Okay. The second one is that it should be made up of line segments. So the key point here is that it shouldn't be made out of curved lines, right? So it should be just made out of simple straight lines. Right, so it should be made up of line segments, and the third one is that it should be enclosed, right? It shouldn't be opened, the lines should be connecting each other. Now let's look at these examples one by one. Let's start by this one. So we see that, okay, yeah, it is a 2D shape and it is flat, it is made out of line segments as well, but if we look over here, we can say that it is not enclosed, so this one would not be considered a polygon. Okay, over here we see a triangle, obviously. So this is 2D and flat as well. It is made out of line segments as well, and it is perfectly enclosed. So this is a polygon. This is a polygon. Okay, over here we see a circle. It is 2D and flat. It is made out of line segments. Nope. So this would not be considered a polygon. It is enclosed as well, but it did not satisfy the second property, right? So this would not be considered a polygon, right? Now looking at this one, this is 2D and flat. Yes, it is made out of line segments. I mean, yeah, these are line segments, but the fourth one ruins it all. So it would not satisfy the second condition, and it is enclosed as well. But since it did not satisfy all of these three, so this would not be considered a polygon. Over here we see a cube, right? This does not satisfy the first condition, that makes this a not polygon. It does not make it a polygon. Okay, over here we see a funny shape, right? It is 2D and flat. It is made out of line segments as well, and it is enclosed as well. So this is considered a polygon. Okay, let's go further and see that there are two types of polygons. The first one is a regular polygon, and the second one is an irregular polygon. When I say regular, that means that the length of all the sides is equal. We see an equilateral triangle right here. So all of its sides would measure the same. For example, this would be 5 centimeters. So all of the other sides would be 5 centimeters as well. So that is what a regular polygon is. And over here in an irregular polygon, it's going to be the opposite, that the lengths would be of different size, right? This would be 8 centimeter. This would be, let's say, 5 centimeter, and this would be 2 centimeter. So this is an irregular polygon. So that goes the same with all of these shapes, right? So over here we see we have quadrilaterals. This one is a square, whereas this one is a trapezium. More specifically, this is an irregular trapezium. Over here we see a funny wobbly shape that is supposed to be a pentagon, but anyways, let's just say that all of these sides are equal, so that makes it a regular pentagon. And over here we also see a pentagon, but the sides are not equal. Same goes for this and this. This looks funny, but it has 6 sides, so this would be called a hexagon as well. Let's look at some of the polygon prefixes, right? So whenever we see pent always will mean 5. So a pentagon would be a 5-sided shape, and a hexagon would be a 6-sided shape. A heptagon would be 7-sided shape. Oct would be 8, non would be 9, and dec would be 10. Right. Now let's get to the last and most the important part over here, which is rotational symmetry and line symmetry. Let's take another color, right? So what do I mean by lines of symmetry? So it means that if I make a line anywhere in a polygon, right, it should, like, there are 2 sides, right? So side 1 should be a mirror image of side 2, or vice versa, right? So how many lines of symmetry are we gonna see? We're gonna try to make the maximum numbers of lines here, and we'll see how many lines of symmetry it has, right? So this line can be made, wait, this is not accurate. It is actually. Okay, this line, and what other line? 1, 2, 3, and it can be this, and it can be this as well, and it can be this as well. So this would mean that this line, this line, this line, this line, and this line will make us lines of symmetry. I know it looks a little, it's not that pretty, not that pleasing to look at, but anyways, all we need to know here is that the number of sides would be equal to the lines of symmetry, or the rotational symmetry is going to be the same as well, right? So but this is only exclusive for regular polygons, right? Here we just have the last example. Let's try to make it a little cleaner. Right, so okay, I'll have to explain rotational symmetry. So rotational symmetry just simply means that if I rotate this polygon at a point, like I rotate it, how many times can I rotate it so that I end up with the same image I had before, right? So that is just the same as line symmetry if you see it in a way. So over here we have 1, 2, 3, 4, 5, 6, 7, 8. We have an octagon right here. It's an octagon. Yeah, it is. Oh, yeah. Okay, so this octagon. So this octagon is going to have 8 lines of symmetry, 8 lines of symmetry, and 8 rotational symmetry, right? Now in your question paper, if you get an irregular polygon, right, so you'll have to manually check by making lines of symmetry to see what the lines of symmetry are and what the rotational symmetry of that polygon is. And this pretty much summarizes our entire topic, which was about polygons and rotational symmetry and line symmetry. I'll see you guys in next class.